All right, hi everybody. So I'm making this tutorial to show how to graph in Desmos. Desmos is incredibly useful to us in graphing our data and also finding the equations that go through our data so that we don't need to do that kind of work by hand, and that sometimes requires math skills that we don't yet have. So Desmos is an incredibly important tool for you to know how to use in this class. All right, so what I'm going to do right now is I'm going to put in some fake data and show you how I would manipulate this. The key here is that Desmos, if you are using one of the links that I provide, you're going to have these equations already put into the program. So when you move this C bar, then you'll see these common patterns show up. And so it's really important that you are using the links that I provide and not just going straight to the Desmos website. Okay, so with that in mind, the very first thing you're going to do in Desmos is to put your data into the data point. You put your independent variable over here and your dependent variable over here. So I'm going to put in some fake data. Notice that right when I've put in a x and y coordinate, it pops up on the graph. Excuse me, 40 and 4. Okay, great. So I've got some data in here. Next, what I will do, so this is showing this is the data. And then with the settings that I have for this particular one, this is the pendulum lab. These orange boxes are telling us how much uncertainty or error there is within the measurement. So, this data point could fall anywhere within here. And those are some presets that were already programmed into this. In this case, this is fake data and it's, lining up perfectly. But I'm going to go ahead and move this bar so I can find one of these that goes through the data. And I see, as I am doing this, that red line is going through pretty well. Okay, there we go. That red line goes through beautifully, and these other ones do not reflect the data. Okay, so step one was to put our data into Desmos. That's step one. Step two was to find the line, to move this little bar and to find the line that went through our data. That was step two. Now we want to clean this graph up by getting rid of the lines that don't match our data. So I see that the red one matches, so I can get rid of this black one. That makes that one disappear. I can get rid of the blue, and I can get rid of the green. Okay, and what this leaves us with is we have our red line, and then we have the mathematical model. It's a different term for the equation. So, okay, so now we're done with step three. We have a line that's going through our data, and now we need to figure out what the mathematical model is. And the mathematical model is what is left over. So I see it's T equals C times S. Okay, CS is like C times S, and I'm using that little star there. You could use the X if you wanted to. Okay, what does T stand for? Well, I'm pretending like this is my pendulum lab data. So T would stand for time. And it's fine to just write time, but I'm gonna go ahead and write it, just the whole dependent variable. Time of one swing, okay, is equal to, I'll come back to the C. The S stands for the angle. I don't know why we used the S there, but this is the angle of release. This, so that we can see that. Okay, time of one swing equals C times the angle of release. Well, our C value is this number right here. That's where I'm getting that from. So the C value is 0.1 times the angle of release. Okay, again, if you're looking at this and this is the pendulum lab, this is not accurate data. Please don't think that this is going to, answer your question for the lab, but this is just showing you how to use Desmos. So when you are writing in your lab notebook and you have something where It's wanting you to indicate the pattern, the equation, or the C value, and the slope. What this would look like is the pattern. Well, this looks like that, straight line. That's going to be a proportional pattern. The C value, I don't need to show my notebook again. The C value is the number that I got, so 0.1. And then the equation would be, I would rewrite this in my notebook. Time of one swing equals 0.1 times angle of release. Okay? So that's how you do your Desmos work. I hope that this is a helpful video.